My name is Alex Kingstrom and I'm a technical manager for the School of Physics, Engineering and Computer Science at the University of Hertfordshire. We are currently standing in our hydraulics lab in our brand new building of Spectra. We very recently moved in July of 2024. We're fully kitted out with TecQuipment equipment and we've had much success with it. The University of Hertfordshire has a long tradition of teaching computer science, engineering, physics, astronomy, mathematics, and we've brought them all together in a school of specs. We focus on, in engineering, we have many degrees. We run automotive with motorsports. We have electrical engineering degrees. We have aerospace degrees, mechanical engineering degrees. We have many computer science degrees. We also do a whole slew of physics, astronomy, mathematics degrees. I've never had anything but fantastic customer support from the sales team as well as the installation team. The technical teams have been fantastic and I would highly recommend them. This is the TecQuipment EC1500 unit, which we use to teach the students about the refrigeration cycle. There's a couple aspects I really like about this piece of equipment. The biggest one being VDAS, which we can get digital readouts of all the information relevant to the experiment. But I also like the physical gauges here. It does help to show what's actually happening in the pressure of the system. We are already connected to the VDAS. I'm going to go ahead and turn on the compressor. I'm going to turn on the pump. And I'm going to collect the data. This piece of equipment is used by both our automotive engineering and thermodynamics students, as well as our mechanical engineering students. I would have to say that my favorite piece of equipment is the 5-meter Flume. I absolutely love it. We've had loads of students run civil engineering projects on the Flume, and I think it's absolutely fantastic.
My name is Vienna Unamba, and I work in the University of Hertfordshire as a senior technical officer in the civil engineering department. In the Flume lab, we have the FC80, which is the Sediment Flume, and students who use it are basically students who do like fluid mechanics or hydraulics. So this is a sluice gate. It's used to close up the flume, not to allow water to come in. So it's like I stop this and no water goes in. And this is a depth gauge used to measure the depth of the water. This is a dye injector, which is used to inject dye into the system. So you see how the dye goes in, the flow of the water mainly used to show how the water flows, especially when it's turbulent or when it's not. And this is the wave generator. It's used to generate waves, as you can see now. So we have the sediment at the other side, but what it does, over a period of time, you can see how the sediment, how the dunes forms and how the effect of the waves on the sediments. So with a wave generator, we can actually create a trough and a crest using the sediments in the Flume. So it can be created over a long period of time depending on how the intensity of the wave generator is, because this is meant to transport. Normally what water does, water transports materials. So we're trying to measure how fast or what time it takes for the sediments to be transported and what kind of shape it gives at the end. It might turn out to be a dune. You have to measure the crest and the trough, how deep, how high. This is a depth gauge, another depth gauge. We have one at the upstream and another one at the downstream. So, and this is our flow switch. This flow switch stops the flow of water. Immediately the water gets to a high level, so we don't have an overflow in the lab. We have the two flumes here. This one is a sediment flume, and the other one is just a 5-meter flume. This flume is without a sediment, so you can do everything. It's easier to say, oh, the final year student can use it for anything, but mainly this is for research and it's for students who really, really, really want to use it, because it's transportation. It just shows how water transports different things, not just sediments, but you can actually use different things in the sediment flume. Using it has been very straightforward, I just came into work and they just told me this is how it works, and it was easy to actually go through it. But for this Flume, we had someone come in to tell us how it works, and afterwards, most of the things we do, it's easy to fix everything in, and it's easy to just like, okay, this is how the button works, and it comes with a manual. So it's easy to just go to the manual, read through it, and then you can be able to walk it through. And then for the blue dye, it comes with the blue dye. It makes it easy for you to measure whatever you want to measure. So it's really relatively very simple to use and straightforward, yeah, I would say.
My name's Lewis Batt. I'm the Principal Technical Officer here in Spectra. And here we have the H408 fluid friction apparatus. It can test 16 different environments that can happen within pipe flows. There are two different types of flows. As you've seen, there's the open channel flow, and this relates to pipe friction. So with pipes, the pressure is exactly the same all the way around it, but there's different environmental changes, such as different 90-degree bends, sudden enlargements and contractions, and all of these can be measured by inserting these tubes and measuring the different pressure before and after the event's happening. This is really good for the students. They can test multiple different scenarios very quickly. They can adjust the flow coming through the whole system and take lots of different readings very quickly and efficiently. It's primarily civil engineering students, but automotive, mechanical, aerospace, a lot of engineering students will need to know about pipes. This will be engines, airplanes, as well as civil engineering. They could be going from a power station into a home. There'll be a big contraction in pipe diameters, and you need to know what those changes are. There'll be different forces involved, and you need to make sure the pipes are sufficiently strong enough to support this and not restrict flow or cause blockages. This piece of equipment is the H7 that shows friction loss in a pipe. In order to show this off more, the pipe is very thin in diameter, so so small changes in the friction would be increased in that with a very small pipe. So the students in this lab can adjust the flow rate. There's a very fine adjustment here, and there's water exiting from the pipe. This is collected and then can be weighed and measured, and the flow rate is then calculated by the students as part of their lab exercise. So the students will use this in civil engineering terms. This could be used for housing or pipelines, subterranean or on ground. Reduction in flow can cause blockages and be very expensive if these things have to be dug up. Aerospace and automotive, mechanical, any engine components, anything that involves fluids, fluids flowing through pipes. This is critical that they need to know these things.